In this flash talk, I'll cover our approach for an automated pipeline for pose estimation. I'll also cover the broader DataJoint Elements approach. So DataJoint Elements is an open source NIH-funded project to disseminate pipelines for neuroinformatics research that covers pose estimation, as well as calcium imaging, as well as EC-EFIS, and we're working on others. So we're all familiar with the process of collecting some form of raw data set, running it through a software package to do the pre-processing for us, give us some intermediate step of data, and then packaging that into an analysis ready for publication. A lot of complications creep in, however, when we think about doing so at scale, doing so reproducibly. So those include developing code and infrastructure that's reliable, that sort of the whole team understands and can work with. That includes complications around data integrity. So what are the procedures in place for taking notes about the good sessions, the sessions that should be thrown out, the analyses or the parameter set used for a given analysis. There are also complications when it comes to opening those data sets to collaborators, maybe outside the university, maybe opening that data set for publication and putting it out into the world for someone to reuse. This diagram covers the broader DataJoint Elements approach. I'll go through each of these individually, but just something to point out here that at the front end, we're working with, or we're integrating with existing packages. In this case, DeepLabCut as a pose estimation software on sort of the front end of the pipeline. And then on the back end, we're working with partners focused on open data and data sharing, including NWB and DANDI archive. I think one key lesson for me in my academic career was building sustainable versioned code. GitHub has really become the standard in the field for not only sharing code with reviewers, but also versioning to keep track of which version of a package, maybe an outside package, was used for a given analysis. Our workflows are similarly managed on GitHub to provide very careful history of which features were added when, what decisions were made along the way. We also take care to produce documentation that covers some of the motivation for each of these workflows and takes notes on which projects informed the generalized workflow that we put out into the community. The data acquisition phase, in my experience, was taking these broader concepts of animal experimental session, neuronal behavioral recordings, and then turning them into some set of files and or notes and or sticky notes that somehow get implemented in a file hierarchy standard. Whenever you turn things into that hierarchy, you have to sort of make some sacrifices about where analyses are. Are they embedded within subject, within session? Maybe there's a software package like DeepLabCut that really demands its own space and has to be matched with recordings from elsewhere. The DataJoint Elements approach is to take all these pieces of information and put it in a relational database where separate tables here represented by these nodes each correspond to some concept, subject, session, video recording. To give you an example, this model table has rows for maybe each of the models that you're training within DeepLabCut. And then the video recording table would have a row for each individual video recording, inheriting the unique identifiers from the subject and session tables. We can then pair these unique rows across these two tables. So the video recording with a set of models or with multiple models, multiple video recordings, the same model in this pose estimation task table. And then a feature of DataJoint on top of this relational database model is this populate command that for a subset of tables has a set of instructions that say this is how information gets populated in this table. That opens the door to some automation, let it run overnight. But that also opens the door to simultaneous computing. So a benefit of having a relational database and a centralized relational database is that multiple collaborators can work on it at the same time, maybe across Python and MATLAB, but they can also be running this populate command on different computer, on different hardware, without worrying about duplicating their efforts. We have a number of different workflows available to run through now in our codebook, Jupyter Hub environment. And then if you're interested in the pose estimation workflow specifically, I'd invite you to go to this GitHub link. Big thanks to the broader DataJoint team, who I've learned a lot from in my role developing this pose estimation pipeline. If you have any questions, you're welcome to reach out to me at this email address here. Thanks for your time.